Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 13. Some potential dangers when solving equations. In previous lessons, we have looked at techniques for solving equations, a common theme throughout algebra. In this lesson, we examined some potential dangers when our intuition about algebra may need to be examined. Okay, some deep stuff here. All right, describe the property used to convert the equation from one line to the next. Okay, so this is an exercise on properties. So pause the video, try this, come back and see how you did. Here we go. So from this step to this step, this is what was addressed. And they multiplied x times 1 and got x, multiplied x times x and got x squared. That is the distributive property of multiplication. All right. Then from this step down to here, x minus x squared plus 2x. All right, so what happened to get from here to here? The minus x squared got added to both sides. Okay, so that is added x squared to both sides of the equation. That would be the addition property of equality. So I'm just going to say added x squared to both sides. That's what we did, but it's called the addition property of equality. Okay, then from this down to here, x plus 2x is 3x, so that was this step here, right there, and I suppose I should have marked this, the minus x squared, we added x squared and it disappeared. All right, so this became 3x, and that is combining like terms. Combine like terms. All right, and then from 3x minus 4, let's see, we added 24 to both sides to get this 20 here. So added 24 to both sides. That's the addition property of equality. So we added 24 to both sides. All right, and then finally, we subtracted 3x from both sides to get 5x. Okay, so that's a subtraction property of equality. So in each step of the above, we applied a property of real numbers and or equations to create a new equation. A says, why are we sure that the initial equation that we started with and the final equation have the same solution set? Okay, well, last class or last video, making use of commutative, associative, and distributive properties and properties of equality to rewrite an equation does not change the solution set of the equation. If you don't know what I'm talking about there, go back and watch lesson 12. Okay, so there's the verbiage. Part B says, what is the common solution set to all of these equations? Well, all I need to do is take that last line, 20 equals 5x, and finish the problem by dividing both sides by 5. And that would leave me with x equals 4. So if I plugged in 4 to any one of these lines, it would be a solution. Okay, page 2 brings us to problem number 2. Exercise 2. So pause the video, see if you can do this, and then come back and see how you did. What it says to do is solve the equation for x. For each step, describe the operation used to convert the equation. Okay, so I'll start with red. you always work inside first. Okay, so I'm looking inside the bracket, and from within that I see this 3 and then multiplied by a group of parentheses here. So working the innermost, I would distribute the -3 here and here. So that would leave me with 3x minus a bracket 8 minus 3 times x. Negative times a negative is positive. 3 times 1 is 3. So that is going to be the bracket equals x plus 19. So there's step 1. Okay, and that's the distributive property of multiplication. Next step I'm going to look at, and I look at these parentheses here, and I am going to combine like terms inside. So I have this 8 and this 3. So 3x minus, and I guess I can use parentheses now because there's not a double parenthesis or a parenthesis within a bracket. And I'm going to write -3x, and 8 plus 3 is 11. And that's going to equal x plus 19. We could call this either the commutative property, order does not matter, what we do in addition or subtraction, what order we do them in, or we collected like terms. Okay, we added the constants. All right, so next step. Now I'm going to distribute that negative. There's more than one way we can do this. Okay, so we're going to multiply. Think of this as a 1 here. We're just going to, oops, hello, I chose blue. We're going to distribute this -1 to these two. So it's going to be 3x. Negative times a negative is positive 3x. Negative times a positive is -11 equals x plus 19. Okay, so that's the distributive property of multiplication. And then on to the next step. And we have like terms now. We have a 3x and a 3x on the left. So we have these two. So 3x plus 3x is 6x minus 11 equals x plus 19. So every step of the way it gets simplified even more and more. So now we have a nice linear term equal to a linear term, and then it's going to clean right up and finish in a minute. So that step was the commutative property again, combining like terms. All right, and then I want to, there's a couple of things I can do here. I like to get all my x's on one side, so I'm going to subtract x from both sides. That will be 6x minus x is 5x minus 11 equals x minus x is 0, 0 plus 19 is 19. Okay, so we subtracted x from both sides, or I could say it's a subtraction property of equality. The next thing I'm going to do is add 11 to both sides. We want to get that variable isolated. So I'm going to add 11 and add 11. That is going to give me 5x, the 11's cancel, equals 19 plus 11 is 30. So that is add 11 to both sides, or we could say the addition property of equality. And now I'm going to finish the problem by dividing both sides by 5. 5 divided by 5 is 1, or just 1x, equals 30 divided by 5, which is 6. So we could say divided both sides by 5, or we could say the division property of equality. And the answer is 6. Okay, number 3 says solve each equation for x. For each step, describe the operation used to convert the equation. So we're going to do the same thing here. So I look, and there's brackets and parentheses, and again we're going to distribute within. So the first step is we're going to distribute this -3 here and here, and that will leave this by itself. I'm going to use parentheses here now. 4x Negative times a positive is negative. 3 times x is 3x. Negative times a negative is positive. 3 times 1 is 3. Always do your signs first so you don't forget. Equals x plus 12. Okay, and that is the distributive property. All right, the next step is we're going to distribute. Actually, we could combine like terms. So this 7x is going to stay here, minus parentheses, and then 4x minus 3x is x plus 3 equals x plus 12. Okay, so that's combine like terms. Okay, so we combine like terms, change to blue for the next step. And now I have this negative sign that I would like to distribute, get rid of these parentheses. So 7x is just going along for the ride. Negative times a positive is negative. 1 times x is x. Negative times a positive is negative. 1 times 3 is 3 equals x plus 12. And that is the distributive property. Okay, so the next step, when we switch to purple, we have 7x and a negative x. Those are like terms. So I'm going to combine these. 7x minus x is 6x minus 3 equals x plus 12. Okay, so that's combine like terms. Okay, next step is get all my x's on one side. So I'm going to subtract x from both sides. And when I do that, I get 5x minus 3 equals x minus x is 0 plus 12 is 12. Okay, so that is subtracting x from both sides. Okay, and then we're going to isolate the variable by adding 3 to both sides. That will leave me with 5x on the left. The 3's cancel, and 12 plus 3 is 15. So I added 3 to both sides. Okay, next step, divide both sides by 5, trying to get that variable down to 1x. These cancel, and I get x all by itself. 15 divided by 5 is 3. So we could say divided both sides by 5, or the division property of equality. And there's our solution, x equals 3. So if I were to put that in a solution set, then it would look like a bracket with a 3 in it. That is the only solution for all of these steps. If I plugged in 3 in any one of these lines, it would be true. Okay, here's part B. Same. So we're going to work inside here. Okay, so I can work on both sides at the same time as well, but I'm going to bring this 2 down. And then this is going to become a parentheses, and I'm going to distribute this 2. So 2 times 3 is 6. 2 times negative 5 is negative 10x plus 4 equals, bring the 5 down, and I'm going to distribute the 2 over here. And that's going to give me a parentheses. 2 times 3 is 6. Positive times a negative is negative. 5 times 3 is 15x plus 2 in parentheses. Okay, and don't forget your order of operations. Work inside the parentheses first. I have a 6, I have a 4, those are like terms. I have a 6, I have a 2, those are like terms. That's what we're going to do. So it's going to be negative 10x. Don't forget that sign stays with that 10x. 6 plus 4 is a positive 10 equals negative 15 is going to come first. Oh, I forgot my 5. Let me erase that. This 5 stays here. Parentheses, negative 15x. 6 plus 2 is 8. Okay, so I combine those. Okay, so we combine like terms. Next step, change colors here. Now I have a 2 outside and a linear term inside. I want to distribute So I am going to multiply the 2 throughout on the left and the 5 throughout on the right. So 2 times a negative 10 is a negative 20x. Positive times a positive is positive. 2 times 10, 20. Equals. Distribute here. Oh, I didn't show my line there. 5 times negative 15x. Positive times a negative is negative. 5 times 15, 5 times 5, 25, carry the 2, 5 times 1 is 5, plus 2 is 7x. And then multiply the 5 times the 8, positive times a positive is positive, 5 times 8 is 40. Okay, I noticed a mistake while I was doing this. So back up here I have 5 times 6 minus 15. Well, it's not 15. 2 times 3 is 6. That's true. I multiplied the 5 times 3, my mistake. It is 2 times 3. So this right here is wrong. So let me fix that. So that is going to come up to be, that is going to be a parentheses. 2 times 3 is 6. That was correct. But 2 times negative 3 is negative 6x. Plus 2. Okay? And then this should be a negative 6 right here. And then, see what happens if you make a mistake at the beginning? It's wrong all the way down through. So now I have 5 times a negative 6. That's a negative 30x. And 5 times 8 is 40. Okay, so now it's in better. That's correct now. And so the next step is, and that was the distributive property, the next step is getting all your x's on one side. So I'm going to add 30x to both sides. And negative 20 plus 30 is 10x plus 20 equals, these cancel, and we're left with just a constant on the right of 40. Okay? Okay, so that was adding 30x to both sides. And now I want to get that variable by itself, so I'm going to subtract 20 from both sides. And these will cancel, leaving me with 10x equals 40 minus 20 is 20. So I subtracted 20 from both sides. Okay, next step. Divide both sides by 10. 10 divided by 10 is 1x. 20 divided by 10 is 2. And therefore my solution set is the set just containing 2. And that last step was divide both sides by 10, or you could say the division property of equality. Okay, moving on to the next problem, part C. And let's start with red again. I like to keep a routine here. Okay, so we have parentheses. We have a constant and a linear term inside. They're not like terms, can't do anything inside. Same over here. So the only thing I can do now is distribute. So the first thing I want to do is distribute here and distribute here. 1/2 of 18 is 9 minus 5 halves x equals 1/3 of 6 is 2 minus 4 divided by 3x. So there's the first step. So that is multiply both sides by 6. Okay, so the next thing we're going to do is, let's see, what can we do here? Okay, I got ahead of myself there. That's a distributive property. I could have multiplied both sides by 6 first, but I'm going to do it here. So now I'm going to, the reason I'm doing this is because in order to get rid of these fractions, you have to find the least common denominator. So I'm going to multiply both sides by 6. 9 times 6 is 54. This 2 will make that 6 a 3. 6 divided by 2 is 3 times 5 is 15. X equals 6 times 2 is 12. And 6 divided by 3 is 2. And 2 times 4 is 8. So we're going to end up with this. So that is multiply both sides by. 6. Okay, so the next step is we want to get all of our x's on one side. So I'm going to add 8x, add 8x. No, actually, if I do that, I'm going to get a negative number, and I don't want a negative variable. Okay, so I want to move the larger absolute value of the variable term. So 15, absolute value of negative 15 is 15, and the absolute value of negative 8 is 8. 15 is greater than 8, so I want to move the greater absolute value linear term to make our variable positive. So we're going to add 15x to both sides. These cancel. I get 54 equals 12, and negative 8 plus 15 is a positive 7x. So I'm going to add 15x to both sides. Okay, next step. I'm going to subtract 12 from both sides to get that variable by itself. 54 minus 12 is 32. 12 minus 12 is 0, plus 7x is 7x. So I subtracted 12 from both sides. Okay, next step. Divide both sides by 7. Oops, 54 minus 12. There's another mistake there. Hang on. 4 minus 2 is 2. 5 minus 1 is not 3. 5 minus 1 is 4. So it's 42 divided by 7 is 6. These cancel, and I get x. So my solution set is the set containing 6. And that last step was divide both sides by 7. Or the division property of equality. Okay, page 3 brings us to problem number 4. And it says, consider the equations x plus 1 equals 4 and the equation x plus 1 quantity squared equals 16. Verify that x equals 3 is the solution for both equations. So all they're asking you to do is substitute in that 3 and prove it's true. So x plus 1 equals 4. And if I substitute in a 3 for x, I'm saying 3 plus 1 equals 4. 3 plus 1 is 4, so 3 is a solution to that equation. If I go over to this one, it's saying the quantity x plus 1 quantity squared equals 16. If I substitute in the 3 plus 1, whoops, yeah, that's right, squared equals 16. 3 plus 1 is 4. Squared equals 16, and therefore 16 equals 16. Now, part B says to find a second solution to this second equation here. So they want us to find another solution to that. All right, so there's a couple of ways we can do this. There's a long way where we could say, okay, well, this looks like it's close to standard, or the vertex form of a quadratic. If I subtract 16 over the other side, my vertex is negative 1 comma negative 16, so it's a parabola shifted left 1 down 16, and that would be the midpoint between two zeros. So going that direction, or I could just think at this step right here, if you remember, a negative number squared will give you a positive as well. So if that was negative 4 right here, okay, then I'm working backwards. So then I would say, well, let's make this a negative 4. How would I get this to be negative 4? So if negative 4 squared equals 16, that's true. So now I want to break this up, and I know that it's something plus 1 squared equals 16. What do I put here to get a negative 4 up here? Well, 1, if I add 1 to something, what was that something to get negative 4? It's negative 5. So negative 5 plus 1 is negative 4. Okay. So there's my other solution, negative 5. Negative 5 plus 1 is negative 4. Negative 4 squared is also 16. So my answer is x equals negative 5. Part C says, based on your results, what effect does squaring both sides of an equation appear to have on the solution set? Okay, so here's my results, and they're asking what squaring both sides So if you square both sides, then you're going to get, let's see, based on your results, what effect does squaring both sides of an equation appear to have on the solution set? Well, if you square both sides, what you do to one side, you do to the other. It doesn't change the solution. So we could say the new equation seems to retain the original solution and add a second solution. So if we squared both sides, then we would have two solutions. All right, part 5. Question 5. Consider the equation x minus 2 equals 6 minus x, and the equation quantity x minus 2 squared equals 6 minus x quantity squared. So that's exactly what they're doing in part 5, is what they're mentioning in C. So they're squaring both sides. So they're taking this and squaring both sides. Did squaring both sides of the equation affect the solution set? So if I just solve this, x minus 2 equals 6 minus x, then I would get, first I'll rewrite it. I would add x to both sides, and I'd get 2x minus 2 equals 6. And then I would add 4 to both sides, and I'd get 2x equals 10. And then I'd divide both sides by 2, and I get x equals 5. But then if I come over here and I squared both sides before starting, then I get x minus 2 squared equals 6 minus x squared. So if I write that, x minus 2 squared equals 6 minus x squared, and I FOIL these, I'll get x squared minus 4x plus 4 equals, and squaring this would give me, first would be 6 times 6 is 36, outer minus 6x is minus 12x, and last minus x times minus x is plus x squared. Okay, so then I would subtract x squared from both sides. See what happens here, and I get negative 4x plus 4 equals 36 minus 12x. And then I would add 12x to both sides to get rid of the x on one side. And 12 minus 4 is 8x plus 4 equals 36. Subtract 4, and let me move this equation in the next problem. Okay, got that next problem out of the way. So minus 4 and minus 4, and we're going to get 8x equals 36 minus 4 is 32. Divide by 8, divide by 8. X equals 4. Okay, for some reason I made another mistake here, and I don't know where I was thinking 4 right here. I should be adding 2. So let me just fix this. Right here should be plus 2 to both sides. I got a different answer, and I'm like, why would I get a different answer? I shouldn't have. Alright, so let me go back here, and I have no idea what I was thinking. Alrighty then. So plus 2 both sides would give me 2x equals 8. Divide both sides by 2x equals 4. So did squaring both sides of the equation affect the solution set? We got x equals 4 on both, so the answer is no. The solution set is still just 4. Okay, so part B says, based on your results, does your answer to part C of the previous question need to be modified? Well, I could say this. The new equation retains the original solution and may add a second solution, but not necessarily. Okay, because we did see that in the prior problem where we did find a second solution, but this one only had the one. Okay, page 4 brings us to problem number 6, and it says to consider the equation x cubed plus 2 equals 2x squared plus x. Verify that these three x's are each solutions to the equation, so we're just going to substitute. So 1 into x cubed, so 1 in for x would give me 1 cubed plus 2 equals 2 times 1 squared plus 1. Okay, the x is a 1 as well. So 1 cubed is 1 plus 2 equals 2 times 1 squared is 1. 2 times 1 is 2 plus 1. Well, that's 3 equals 3, and that checks. Now I'm going to try negative 1. So it would be negative 1 cubed plus 2 equals 2 times negative 1 squared plus a negative 1. Negative 1 cubed is negative 1 plus 2 equals negative 1 squared is 1 times 2 is 2 plus a negative 1 is minus 1. So negative 1 plus 2 is 1 and 2 minus 1 is 1. So that is a solution. And then finally we're going to try 2. 2 cubed plus 2 equals 2 times 2 squared plus 2. 2 cubed is 8 plus 2 equals 2 squared is 4 times 2 is 8 plus 2. And as you can see, 10 does equal 10. We verified all three solutions are solutions to this equation. Part B. Bonzo decides to apply the action, ignore the exponents on each side of the equation. He gets x plus 2 equals 2x plus x. Ignore the exponents. So let's see, he just said x plus 2, so we ignored that 3, equals 2x plus x, so we ignored that 2. I see what he's doing, okay. What does he obtain? What seems to be the problem with this technique? Well, if you solve this, x plus 2 equals 2x plus x, and I solve this, then I'm going to subtract x from both sides, and that is going to leave me with, well, I could do this first, x plus 2 equals 3x, combining like terms, then subtract x, and that would leave me with 2 equals 2x, and therefore x equals 1. So now I only have one solution. Okay, what's wrong with this? Okay, so the problem is he only finds one of the three solutions to the equation, x equals 1. He did not find x equals negative 1 or x equals 2 by just canceling those variables. Okay, part C. What would Bonzo obtain if he applied his method to the equation x squared plus 4x plus 2 equals 4x is a solution to the original equation? Okay, so I'm thinking they want us to have him do what he did before and ignore the variable here and here, and that would give us x plus 4x plus 2 equals x. 5x, combining these like terms, plus 2 equals x. Subtract x from both sides, and that would give me 4x plus 2 equals 0. Subtract 2, 4x equals negative 2, divide by 4, come over here, x would equal negative 1/2. And so it says, is this a solution to the original equation? And the answer is no. The solution to the original equation, these solutions, one of the solutions, 1, negative 1, and 2 is not negative 1/2. So no, his solution is not one of the three solutions. So you can't just cancel exponents and ignore them. Not a mathematical process that works. Okay. Part 7 says consider the equation x minus 3 equals 5. Multiply both sides of the equation by a constant and show that the solution set did not change. So how about 4 times x minus 3 equals 4 times 5. So I multiply both sides by 4. This would give me 4x minus 12 equals 20. If I add 12 to both sides, I would get 4x equals 32. Divide both sides by 4, and I would get x equals 32 divided by 4 is 8. If I plugged in 8 into the original, 8 minus 3 is 5, so the solution is the same because I multiplied both sides by a constant. That is a multiplicative property of equality. What you do to one side, you do to the other, does not change the solution. It says now multiply both sides by x. Okay, so if I do that, it would be x times x minus 3 equals x times 5. That'd give me x times x, which is x squared, minus 3 times x, which is 3x, equals 5 times x, which is 5x. Alrighty, so in this situation, I would move the 5 over to this side by subtracting 5x. And when I do that, I get x squared minus 8x equals 0. So let me bring this up here. X squared minus 8x equals 0. Factor out an x, I get x times x minus 8 equals 0. So x equals 0 for this piece, and x equals 8 for this piece. So multiplying both sides by x gave me another solution, x equals 0. Okay, so it says show that x equals 8 is still a solution to the new equation, so that is right here. Okay, page 5 brings us to part C, and it says show that x equals 0 is also a solution to the new equation. Well, I've already done that. Okay, so it is right here, x equals 0. So that was, I did all of that in 7a. So 7a answered both 7b and c. So now it says to multiply both sides by the factor of x minus 1. Okay, so part B said to multiply both sides by x, and our original was x minus 3 equals 5. So in continuing this, if I multiply both sides by x, like it said here in 7a, now multiply both sides by x, that would give us this equation. Both sides multiplied by x would look like this. And it says now multiply both sides by a factor of x minus 1. So then that would give me x minus 1 here and x minus 1 over here. Okay, so part D now says show that x equals 8 is still a solution to this new equation. So what would I do? I'd put an 8 in for all these x's. So it would be parentheses 8 minus 1 times 8 times x minus 3 equals, why did I put an x? X is supposed to be 8. 8 times 8 minus 3, right? 8 minus 1 times 8 times 8 minus 3 equals 8 times 5 times 8 minus 1. Well, 8 minus 1 is 7 times 8 times 8 minus 3 is 5. So I'll put all these in parentheses if you wish. And then that would be 8, 5, 7. So as you can see, I have all three numbers the same on both sides, so that would definitely be true. And 5 times 8 is 40, and 7 times 4 is 28, so that'd be 280 equals 280, so therefore it's true. Now part E says, show that x equals 1 is also a solution to the new equation. So if I made x equal 1, it'd be 1 minus 1, I'm putting a 1 in for the x up here, times 1 times 1 minus 3 equals 1 times 5 times 1 minus 1. Well, that's going to be 0 times 1, and it doesn't matter if the first term is 0. 0 times anything is 0, and 0 times anything is 0, so we still get the same solution. F says, based on your results, what effect does multiplying both sides of an equation by a constant have on the solution set of the new equation? Multiplying it by a constant does not change the solution set. And now finally part G says, based on your results, what effect does multiplying both sides of an equation by a variable factor have on the solution set of the new equation? Okay, so multiplying by a variable factor could produce additional solutions to the solution set, but keep in mind that it's not always going to happen. So if we use this word right here, could, not necessarily. Okay. Okay, page 6 brings us to the end of lesson 13. Review the lesson summary and go do your problem set.